Hi everyone, let's solve today's daily challenge, that is some root to leaf numbers. So we have a root of a binary tree which contains digits from 0 to 9 only, and each root to leaf path in the tree represents a number. For example, here the root to leaf path 1 to 2 to 3 represents the number 123, and we need to return the total sum of all root to leaf numbers. So let's see what the question is. So here you can see this tree, right? So here what we have to consider all root to leaf numbers. So here we can see we have two leaves, right? So root will be single only. So if you want to consider, we have to, check what leaves we have. So here we have two leaves. So we'll be forming two numbers. So from 1, if we, go to 2, we will have this path, right? We'll be following this path 1, 2. So our number becomes 12. Then we are going from 1 to 3. So our number becomes 13. So what we have to, so that is it. These are all the root to leaf paths here for this particular tree. So what we have to do, whatever numbers we get from all these root to leaf paths, we have to sum them up. So when we, sum these numbers, we get 25. So that is our output. That is what we have to return. Right. So let's understand it with this test case. So here what we have 4 as the root node. Correct. Let's see all the root to leaf paths here. So here you can see from 4 to 9 and 9 to 5 is one path. So let's write it here. We have 4 to 9 to 5. So this basically becomes a number 495. Then we have another path from 4 to 9 to 1. So this becomes 4 to 9 to 1. This becomes 491. Correct. Now we have another path from 4 to 0. So from 4 to 0, which becomes 40. Right. So we have written all the paths root to leaf node. Correct. So now what we have to do, we have to sum up these numbers. So here we sum them up. What we will get? We will get 1026. Right. So this is what we have to return. Correct. Now, so I hope you have understood the question. Now let's see how we'll be, approaching this question. How we'll be solving this question. So there is one very basic property that we need to follow. Correct. So let's see. So first, whenever we see, a question of tree, two things come to our mind, right? That is DFS and BFS. Correct. So we'll be solving this question using BFS. This question can also be solved using DFS, but here we'll be solving this using BFS. Now let's see how, we'll be solving it using BFS. Right. So here one fundamental property that will help us, to solve this question using BFS is that whenever we sum up the numbers, right? So we follow, the places, right? So here you can see what we do is we sum up the digits at the first place, right? So this is the first place, we can say. We sum up the digits at this particular place. Then we sum up the digits in the second place. Correct. And then we sum up the numbers, the digits at the third place. So here, so you can get some idea, like, so these are kind of levels, right? So let's see how these are levels, right? Okay, so we have 4 here, right? So we'll be starting from the root node. Correct. So we have 4 here. All right. Now when we go to the next level, what we have to do, right? We have to put this 4 to the next place, right? In the digit, in the number, right? So this was at the first place. Now this should go to the second place. So what we'll get? We'll get 4 here, and 9 should come here, right? That is how we form numbers. Correct. Then what do you do? Then from 9 you can see it, like, it is not the leaf node. So you need to consider these two nodes also. So now what you will do? Now what you have to do? 4 should move to this place and 9 should move to this place. Right. So what we'll do? So we'll have 3, 2, 1 here, and 4 will move here, 9 will come here, and 5 will come here. And similar thing will be happening for, this particular position also. So it will be 491, it will become 491 similarly, right? In this way only. And here you can see from 4 to 0, this is the leaf node, correct? So this number, when we'll be, traversing for this number will be formed as 4 and 0, because after 0 we don't have anything, so no, we will not be moving any number to any place when we reach a leaf node, because we cannot, right? So this is how we have levels. So you can see that we are having some levels here, correct? So these are what levels are, and this is why we can apply BFS here. So what we are doing is we are basically first calculating for the first level, then we are coming down to the second level and shifting values. Then if there exists one more level, then we are coming down to that level and shifting values, correct? So this is basically what we are trying to do. So this is how so how we have understood the idea of levels here, right? So now let's see how we can apply BFS here. Let's discuss the whole algorithm now. Let me rub the whole board. Okay, so one thing is, whenever we are doing BFS, what do we consider? We consider a queue, correct? Now here, another thing you need to notice is that, see, our queue should, ideally in BFS, what does our queue contain? It contains a node. But here, one thing we also need is the sum, right? Whenever, when we were at this particular node, so we did not have, just 4 or just 9. We had 49, right? So we need to remember this when we go to the fifth node or when we go to the first node. So the node with value 1 or node with 5 value, correct? So we need to remember 49. So how are we going to remember that? So we can, we can pass another value inside of the queue. So we can, what we'll do is we'll be passing the pair of a particular node and this particular sum value. So our queue will be containing this. Now let's see how we'll be doing the BFS. So first we'll push this particular node and we will say, the sum at this particular node is 0 only, right? So we have not discovered any, discovered any route to leaf path yet. So right now the sum is 0 only. Then what we'll do? We will be iterating inside of the queue. So first we will see if this has, like, see, when we will be iterating inside of the queue, we will be having one base condition. What will be that base condition? That base condition will be that if you don't have anything, no children of a particular node, that is, if the node is leaf node, then what you have to do? You have already got the sum, right? This sum variable will basically contain your, number here. Right? For example, when we reached 0, so our number found was 40, correct? But when we reached here so our number found was 491, so we have to stop here, correct? So this will be our base condition, and when we arrive this base condition, we have to add it. We will consider an answer variable and we have to include this particular value in our answer, that is, add this particular value in our answer, correct? So this will be one base condition, that is, when we reach the leaf node, we need to add it inside of our answer, right? So right now our answer will also be 0. So let's start iterating. So first our queue contains 4 here, right? So now okay, wait, we draw the queue here. Our queue contains 4 comma 0 here, correct? Now what we'll do, so we have not arrived a base condition, so our answer will not contain anything. What we will do, we will pop this out and we will put its children inside of the queue. So what we'll put here, we will be putting these particular nodes plus the sum that we are currently at. So what will be the sum at this particular node? So what we'll be getting is 4 into, what we'll say, see, if we want to shift a particular value by one place, we multiply it by 10. So that is what we are going to do. Whatever value we have inside of sum, we will multiply it. Okay, so first this will happen for this particular node when we are, we are iterating inside of the queue. Before we have, put these here, our sum that we, we will be calculating the sum as whatever the value you currently have, you multiply it by 10 plus you add the value of the node. So here our sum becomes 4. Then what you will do, you will push this particular sum plus these nodes here, right? So we'll pop this out from the queue. So we will get here 9, comma, so what is this, 4, and you will get 0 comma 4, right? Now what you will do, first you will calculate the sum for this particular node. So if you calculate the sum for this particular node, you will be having 4 here, right? This particular sum here, this sum you will put here, and you will be having the value of this node here. So you will get 49 here, correct? Similar thing you will do for this. So we are not currently at this particular node, we are only at this particular node while iterating inside the queue. Then what we will do, we have to pop this out, correct? And then we have to also make function calls to, sorry, you will push its children inside of the queue, right? So before you pop this out, you will just push 5 here and the sum you currently have, and you will have 1 comma 49 here inside of the queue, correct? So we have these values. Now you will be reaching at this particular node with 0 comma 4. So what you will do, you will take the 4, right? So now you will see that this node has no children. So if this does not have any children, we will be arriving at the base case. So in base case, first we will calculate our sum here. So the sum will become 4 into 10 plus 0, which is 40, right? So this is the leaf node, right? 0 is the leaf node. It will not have any children. Then what we will do, we will add it to our answer. We will add it to our answer. So our answer will now become 40, correct? And we will pop this out. Then we will reach these two nodes, right? So right now we will be at this particular node. So when we are at this node, what we do, we shift these two numbers 4, 9. So what we do, we multiply them by 10 plus what we add 5. So what do we get? 495. Then you will you will check for the children here. So there are no children. So if there are no children, that means it is the leaf node. So we need to add this number to our ans. So what we will do, we will add 495 to 40. So what we will get, our answer will contain 535, right? So our answer will get updated to 535. Then we will be arriving at this particular, we will pop this out and we will be arriving at this particular node. Again, you can see this is a leaf node. So what do? We will have 49 into 10 plus 1, right? The value of this particular node. Then because it has no children, that means we have arrived the base condition. That is, we need to, this is the leaf node and we need to add, we have got an answer, right? We have got a number and we have to add it in our answer variable. So we'll add 535 to 491. So we will get 1026, right? So you see, this is how, this is the algorithm and this is how we are using BFS and the Q data structure to calculate an answer here, right? So now let's see the code for it. So here we have a variable sum for calculating. So this is nothing but answer variable, and we have our Q, right? So as I said, because we need to remember the last sum, so we are passing this int here. So we are kind of having a pair in which we will be having a tree node plus the sum that we got from the upper levels, right? So first we will push the root here, and the sum currently is 0 because we have not reached the leaf yet, right? So now we are iterating inside here, right? We are iterating inside of the queue here. So first what we'll do, so we will be taking this is the first and this is the second value of the pair. So this is our node, correct? And this is our sum, whatever current sum value we had. Then we will pop this out, and here we are updating the current sum for the next iteration, for passing to the children of this particular node that we currently are at, correct? So we have the sum and we are multiplying it by 10, that is shifting those digits by 1, correct? And we are adding this node's value here. Then we are checking, this is the base condition. So if there is a base condition, we have to consider it as a number and we have to add it inside of our answer variable. So this is the sum variable here. So what we are saying if there are no children of this particular node, that if it is a leaf node, then consider this as an answer and add it here. then if this is not true, that means we have children, right? So if so we will make calls for the, sorry, we will not be making calls, we'll be pushing the values of the left and the right children inside of the queue, right? So this is basically what we have to do. So after our queue will get empty, we will get an answer here, so we'll return it. So that is how we have to solve this question.